Okay, so let's look at how we can put some charts together for numeric variables. And there are a lot of graphical ways to kind of look at the distribution of a numerical variable. So if we have cross-sectional data, we can look at histograms and box plots, also known as box and whisker plots. And then for time series variables, we do have the time series graph. So the first thing that we're going to look at is histograms. And histogram is probably the most common chart type for showing the distribution of a numerical variable. And that's where we get back to this idea of binning. So we're going to divide the variable up into discrete categories. And when we look at the baseball example, you'll see that we're going to do that, and we're going to bin it by salary. And then we're going to basically count up, okay, well, how many baseball players make between $500,000 and $1 million a year, and then $1 million and $1.5 million, and then $1.5 million and $2 million, and we're just going to count it up, and that's going to give us a distribution, a frequency distribution of what's going on. And so it's going to be shown as a column chart. And there's going to be no gaps between the vertical bars, and we can just go and take a look at it. So a histogram is great for showing the shape of a distribution. And so we're really going to be able to look at that and know whether or not it is skewed in one direction, because we can see how the frequency comes together. And so this would be a histogram. And this is actually a poor graph because I don't have axis labels on here, so you don't know what this is. So along the y-axis, this would be number of instances that happens. This would be our frequency. And along the bottom here is our salary bins. Now, once again, this is taken right from the book. It's formatted poorly because you can't look at this, and one, you don't know what the category is, but two, you can't see the two ends of the variable, because typically you would see both ends so you know what the bin is. So if we were doing this in class, we do it a little bit different to make sure it's labeled, but this shows us, this gives us the shape of the distribution, and in fact, we can see that this is a positively skewed or right skewed distribution because the tail is definitely going this way. That's our mode way up there, so we can kind of see that it's definitely way skewed that one way. The other one is a box plot or a box and whisker plot, and this is another good one for comparing distributions. This is not very useful for one distribution. So as you'll see in the example, we're going to do a box plot, and it's not going to really give us any data. But next week, when we go back and look at it again, we start looking at the distribution side by side, we will get some very interesting data. So box plots are a complementary way of displaying a numerical variable, and they will show us the first and third quartile, the interquartile range, and all that great stuff. So if I go, and this would be a box plot. So this is a box plot of our baseball salaries that we're going to look at. You can see that this is our salary going on here, and so this is kind of what the box plot looks like. Now you'll notice that this is called a whisker. We don't really have one of those coming up the other side because it's so tight in. It's right in there. But let's just talk about what this represents. So this bottom line here, that would be our first quartile. The top line here would be the third quartile. So this box itself represents the interquartile range. The X in here, that represents the average. So that's the average of everything. And then this straight line here, this is our 50th percentile or our median. So there is just as many instances below this line as there are above this line. So what does this little line here represent? This is what we call the whisker. And the whisker extends on either side of a box plot by 1.5 times the interquartile range. Why do we do that? Well, remember, the interquartile range we like because it kind of is more stable than everything else. And so since this whisker pops out 1.5 times the distance of the interquartile range, it's a useful way of identifying outliers. Basically, we'll talk about outliers in a minute, but it's data that's kind of outside of the data set. And so all these little points that you see here, these would all be things that are outside of that interquartile range. When we plot this stuff in Excel, that's the kind of thing that Excel will plot out. Actually, in Tableau, it will plot out all the data points, but that's the way Excel does things. And you can take a look at it and you can see within a box plot how a distribution is skewed. So a normal distribution, so we got the whiskers on either side, the 50th percentile, the median is, the median is in between the first and the third quartile. Okay, now we see the median gets pulled down to the left. This is positively skewed because the only way that the second to third quartile would be this big is if we've got some big numbers over here kind of dragging the entire thing up. And negative skew, we've got the same thing. We can see we've got this bigger range between the first and the second quartile. And then this is what it would look like, just another chart showing that stuff. And we can see, oh, well, this one is negatively skewed because it's bigger here. Negatively skewed, bigger here. All these are negatively skewed. Just a way to look at things. And so now with that, we're just going to go right into example 2.3, baseball salaries. We're going to calculate all those measures of central tendency, all those variances, standard deviations, and we are going to put together a box and whisker plot and a histogram.